Dear colleagues, let's begin our morning session. The first speaker is Maria Skopina from St. Petersburg. The title of the talk, Wavelet approximations in Orlicz spaces, please.
Thank you for introducing, and of course, thank you to organizers for inviting me here and for this talk. I have to start. Have to say sorry that my topic is not close to the interest of most participants, and especially to the hero of this event, Professor Samko. Nevertheless, there exists a non-empty set who touched wavelet theory here. Okay. So, wavelet approximation of Orlicz spaces, joint results with Alexander Krivoshein. What is wavelet system, multivariate wavelet system? It is as attack. A multivariate wavelet system is associated with the matrix M, which is called matrix dilation. This matrix such that all eigenvalues are bigger than 1, strictly bigger than 1, and small m is absolute value is determinant, and the system is scales dilations and shifts and integer shifts of finite number of functions psi L, and psi. These functions are called wavelet functions. Important property of wavelet system. Where vanishing moment property of order S means that as moments of these of wavelet functions vanish, in terms of the Fourier transform, it looks like this. What I'm going to present, two topics. First, approximation properties in Orlicz space for wavelet frames or bases, in particular bases, and for second for so-called frame-like wavelet systems. I remind what is wavelet frame. First, what is frame? Frame in a Hilbert space is a sequence such that there exists positive constant A and B, for which this two-side inequality holds for any function f from H. If A is equal to B, such frame R is mixed. Such frame is called tight frame. If only the right-hand inequality holds, then we say that the system is a Bessel system. The main property of frames for any f from H, from the Banach space H, Gilbert space H, the following decomposition holds, and f and tilde is also a frame. It is called a dual frame. This is generalization frames, and this decomposition are generalization of basis. For the case of tight frame, this is generalization of orthogonal basis, orthonormal basis, and in the general, this is a generalization of here, the generalization of biorthogonal basis Fn, Fn tilde. But frames are redundant system. In the case of, I said already, in the case of tight frame, this is the same. Phi tilde dual frame coincides with original frame. Now we discuss wavelet frames. This means that wavelet system is a frame, and frame decomposition looks like this over all wavelet functions, over all shifts, translators, shifts, k, and over all dilations. Doesn't work. Да? Там никого нет. Есть кто-то. Okay.
Excuse me, what is new? Example. The second sum is over new. What is new?
New, it is L. New is equal to L. Mistake, thank you. And here also new. Sorry. Next, I want to say that wavelet frames usually are not falling from the sky. They are constructed. There is a method of construction. And for those who is familiar with wavelet theory, knows that this method is based on so-called multi-iteration analysis, but what is important, they are constructed from two functions called scaling functions, and wavelet expansion, this one, can be rewritten in this form, where first term is just, we see just scaling functions. Okay, so this is also wavelet expansion we discuss. More details from phi and phi tilde. One constructs dual wavelet frames using so-called matrix extension principle. Doesn't matter what this means, but I will say constructed by map. Constructed by map from phi and phi tilde. And the following equality holds, so this is wavelet expansion, and the same may be given in this form via phi and phi tilde scaling expansion. We will write this, and this is also wavelet expansion. And the simplest example, first, the simplest wavelet frame fall down from the sky. It was more than 100 years ago. It was sketched by Haar, and this is Haar system. This is a basis, orthogonal basis, the same, one-dimensional case, and only one function without index. And it is classical hard system is constructed by map, may be constructed by map from this scaling function, characteristic function of 0, 1. Now I'm going to approximate an Orlicz space, and this is my first traveling to this topic, Orlicz space. Maybe not everybody touched this. I will give all necessary information. Orlicz space is associated with a function theta. Such a function is called a Young function if it is convex and it is equal to 0 if and only if x is equal 0. And we introduce this function now. Next, we introduce Orlicz space. L theta is Orlicz space. It consists of functions measurable and such that this functional, this vector lambda, is finite for some lambda. There exists at least one lambda. And another space, E theta, the same but for all lambda. Sometimes this is called large Orlicz space and this is small. Of course, this is subspace of E theta is subspace of L theta. And what is it? Modular convergence, a sequence modular converge to 0 in L theta if this relation holds for some theta, in E theta if this relation holds for all lambda. And norm, there is norm in Orlicz space. This is a Luxemburg norm defined like this, and here L theta and this norm, Luxemburg norm, is a Banach space. It's easy to check. And so we have two types of convergence. One, this one, and another one, norm convergence. For the small Orlicz space, sometimes I said this is large Orlicz space, and this is called sometimes small Orlicz space. In small Orlicz space, modular convergence is equivalent to norm convergence, but not for L theta. And now I'm ready to present a theorem about wavelet frames. Let S is the positive integer, F in Sobolev's Orlicz space. What is it? Sobolev Orlicz space, the same as in the case of LP. LP space is, of course, special cases of Orlicz space, and the same derivative of order S in Orlicz space. Next, suppose this is dual wavelet frames generated from scaling function phi tilde by map, and these functions are Bessel. Next, this assumption, and the system psi jk tilde has BMS property, and next, all these functions have good decay. Nu then where nu is radial decreasing function and such like this, then we have inequality. We see this approximation order S, and what is rho? Rho is arbitrary number which is less than any eigenvalue of M, but in the one-dimensional case, M is a number and rho may be taken equal to M. Okay. So we have we obtain approximation order for modular convergence. Next, we
rho should be strictly less than any.
in the general case, yes, any eigenvalue and given values are bigger than 1. Eigenvalues are strictly bigger than 1. If this is the diagonal matrix, the same values, then we can just take determinant as in one-dimensional case. In general case, okay, now we restrict a little bit class of functions theta. They satisfy the two conditions. If this holds, this condition is necessary and sufficient for equality L theta. This is for, there exists lambda, exists any, and this, for such function, this is the same. Functions, this is correspond to LP with logarithm, another form of logarithm, and this function satisfies delta 2 condition, and Young function exponential, this one do not satisfy delta 2 condition. We will consider now delta 2 condition because we want to have to discuss norm. And the theorem absolutely the same is assumed, but here only one difference. Now theta satisfies delta 2 condition, all the same, and we have such an inequality for norm. Here now it is norm, and this is norm in Sobolev space. But let us compare this theorem. In the case of LP space, this is LP norm. And in the previous theorem, what is this? This is LP norm under the power P. So for P bigger than 1, it is not good. It is not good. Maybe that first theorem should be improved. But not so bad, because we have an example. This theta does not satisfy delta 2 condition, and the estimate is sharp, cannot be improved for this function. But of course, for some other functions, this is really not good. How to improve? We can write in this form. What is this? In the one-dimensional case, it is actually m under the power minus is. Anyway, this goes, tends to 0. But this not beautiful, because not attractive, because we do not see approximation order. This factor is inside of functional. However, taking concrete function, we can obtain approximation order. For example, this function doesn't satisfy delta 2 condition, and we can compute and obtain the second order in this case. Okay, next, I have no time to explain in more details what is frame-like system. I will read. Using the construction of dual frames by map, one has overcome essential difficulty to provide vanishing moments for all wavelet function, which is necessary. Really, this is not easy. There are many constructions, but they are complicated. However, engineers do not take care of this, providing vanishing moment only for the function psi And they successfully applied such frames which are really not frames. But they work with this and in signal processes and consider that it is very good. Say, oh, we used frame and this is a good frame. That's why about 10 years ago we developed such a theory to construct frame-like wavelet systems, which are not frame really, what engineers consider that they are frames. And generally speaking, actually starting with arbitrary trigonometric polynomial, we can construct such a system. Generally speaking, these are tempered distribution, but in concrete situations, it may be in LP space, in Orlicz space, anywhere, and we can discuss. I miss all this. I have no time about construction. How? So construction, such a construction exists. What happens in LP? In LP, it was obtained. It is well known. First of all, this scaling expansion, the same as Wavelet expansion, is an LP, and approximation order S whenever vanishing moment condition is satisfied. And what we discuss Orlicz spaces. So LP is Orlicz space. Can we obtain the same? What is LQ? Analog of LQ exists? Yes, there is a conjugate Young function theta star defined like this. And further inequality holds complete analog of LQ. This is LP and this is LQ. And I was absolutely sure that we must prove, and first we need to prove this. But I tried several times and could not. I could not understand what happened. It should be the same. Because of technique, we assumed a little bit more than delta 2 condition, so-called delta prime condition. If it is satisfied, then delta 2 condition is also satisfied. But I could not understand one. I cannot prove so simple thing. But later, I found a counterexample, theta as logarithm, and function. It's possible to check phi tilde is this function. Phi tilde is in this space. This is checking, but this is infinite. Just it's possible to compute, and phi is just characteristic function of 0, 1, and f is given like this, and we have infinity. So there is no analog, but because of this, we considered phi tilde is an L infinity, and in this case we have this inequality, and Wavelet decomposition is also can be presented as scaling decomposition, and we have the following theorem. Now we assume that theta satisfies delta prime condition. Then suppose phi in L theta and phi tilde is in L infinity. I explain when we cannot take dual Orlicz space. Are refinable compactly supported functions and psi JKL, psi tilde JKL are dual Wavelet system generated from this scaling function by map, and psi tilde L have a vanishing moment property of order S. Then we have approximation order S as the same as in the space for equal spaces. Thank you very much.
Are there any questions?
А вот все-таки с этим роликом.
В одномерном случае это просто вот m это число, и оно же m.
Давайте обсудим. Есть такое подозрение.
Ну, это со спектральным радиусом связано.
Я понимаю.
Да.
У меня есть такое подозрение.
More questions?
Let me ask a question. My question is the following. If we do not impose the doubling condition on the Young function, then, as I understand, we do not have the norm convergence. But the question is it possible to give some counterexamples?
Sorry, about
In case you don't have delta condition.
контрпример к чему?
Что если вы отказываетесь от doubling condition, то у вас не будет сходимости по норме.
Нет, yes, but if we have no delta conditions, this is not the same. Norm convergence and modular convergence. And modular convergence exists for all functions, but no, just shows that, no, it's impossible. If we take function which is not, it itself is not on Orlicz space, so we cannot discuss this type of convergence. Exponent.
Yeah, exponential function is what I mean. So, what, as I understand, such counterexamples really can be given.
No convergence, no norm convergence. Because if we have norm convergence, then we have convergence in small Orlicz space, EP. But this is not so for function which is not in Orlicz space.
So you have another
A small Orlicz space.
From another understanding.
Okay. More questions?
Let me ask one question, because I think we already discussed this crocheting. Since you impose the delta condition, maybe you can use, when you estimate, maybe you can use kind of interpolation between these spaces, because Orlicz space and Orlicz norm you can obtain by interpolation between these spaces. Or maybe just think about it.
We did not think about
You never
it.
used interpolation in your estimate.
No, did not think very direct proof. Direct proof for Wavelet, this is natural because we do not estimate scaling operators. In LP space we study. Today I do not know how to estimate.
I mean that you know results for LP space. And
no, I understand.
okay.